What I'm about to show you is how a structure that you would do any statistical test or anything, any experimental analysis, anything, you would try to use this structure. The idea of having a standard structure when you run a statistical test is try to avoid bias. So there are widely accepted statistical procedures, and null and alternative hypotheses is one of them. So when I have a book for this class, it's optional, but it would help you get a grounding. So this isn't the first time you've seen this. But data analysis with R, this textbook that I assigned, says to assume the opposite of what you're testing. Try to show the results that you receive are unlikely given that assumption and reject that assumption. That'll make more sense in a second. So why do we assume that we're wrong? Because of bias and a self-fulfilling prophecy. So always assume that there is no relationship in whatever you're looking at. So if you are looking for a specific answer, there's always some way to either consciously or unconsciously manipulate the statistics to get a result that fits your hypothesis. Might not be good statistics, but there is always a way to do that. So we are trying to account for that because that happens consciously and unconsciously. And then when you read anything, read the methods, because sometimes, especially in news articles, it won't make sense. Like they'll say, oh, this shocking thing, and then you'll go in and you'll read what they're talking about. You're like, oh, okay, so that doesn't really mean anything. So that happens a lot. So you would want to follow these guidelines that I'm going over to try to actually get to the correct answer versus what you want to find. So that's where null and alternative hypotheses come in. So the null hypothesis, and I'm going to give a bunch of examples and have you write them either on the computer or I have worksheets. I think it's easier sometimes to write things down, so I did get those. So it assumes that any significance or difference that you're seeing when you're running your statistical test is due to chance alone, that there really is no relationship between the two things that you're looking at. It's always your default. You always assume that there's no relationship. And then you have to assume that you have to prove that is not true in order to say, find that there is a relationship. So, yeah, so when there's a lot of noise, in my head, I lose my train of thought. And so if we could turn off devices, it's hard for me to concentrate. So we have to establish statistical significance, we have to reject this null hypothesis, which shows no relationship. So our alternative hypothesis is fit to what we're looking to find. So it's going to always be the exact opposite of our null hypothesis. So if we're looking to see if two means are statistically significant, their difference is statistically significant, then our null hypothesis is going to be that they are the same. And then our alternative hypothesis is going to be they are different. So that's what we're actually looking for. And then you have to use your statistical test to reject that null hypothesis in favor of our alternative hypothesis that we're going to see in a second. And so it's what you're trying to prove. So we have to, and I think that this metaphor works pretty well. When I was looking through the websites and how to explain this, the justice system metaphor works pretty well here. So the null hypothesis is basically the same thing as innocent until proven guilty. When you're saying that, you're not saying that they're innocent. You're not saying that they're guilty. And we're assuming that we don't know. But when we say we go through the justice process and they have a jury and then they decide that this person is guilty, then we have rejected the null hypothesis of innocent until proven guilty. So you can think of it that way, and I think it's really pretty easy to think of in context. So this is what it actually looks like. I'm going to go over 4 examples, and then I made a worksheet which also has more examples plus, so you guys would write. So what we are testing. So we're finding that we are looking to test more than 30% of registered voters in Travis County voted in the primary election. That's what we want to know. So is it more than 30%? So our null hypothesis, we're assuming the opposite of that. So it would be that it's less than or equal to 30% of registered voters in Travis County voted in the primary election. So we are assuming that what we're testing, that we are wrong. And then our alternative hypothesis, what we're trying to prove, would be that greater than 30% of registered voters voted in Travis County in the primary election. So this is how we would set up a statistical test. The next example is a drug reduces cholesterol by 25%. So our null hypothesis is it does not reduce cholesterol by 25%. So it could be more or less. And then the alternative hypothesis is it reduces cholesterol by 25%. So that's what we want to prove. Couple more examples. Go ahead, somebody.
Null is equal to no or is.
So you have to, this is the tricky part about it. So we are saying it actually reduces it by 25%. So it's the null and alternative hypothesis would be equals to and not equals to. The reason is if we said that the drug reduces cholesterol by less than or equal to 25%, then our null hypothesis would be greater than 25%. Does that make sense? So this is why I go over this, because it's a little tricky. And this is also a great example. These came from a website. I would not have probably phrased it this way, but you have to keep that in mind. So that's why it is. So if it's greater than or equal to, then the opposite would be greater than. So hopefully that makes sense. And that's a tricky part about it. So make sure you read these carefully. So another example is we want to test whether the mean GPA of students is different than 2.0 out of 4.0. So our null hypothesis would be the mean GPA of American colleges is 2.0. We want to prove that the mean GPA of colleges does not equal 2.0. And then we want to test if college students take less than 5 years to graduate from college on average. Our null hypothesis would be the mean years that students take to graduate from college is greater than or equal to 5 years. Our alternative hypothesis would be the opposite of that. The mean years that students take to graduate from college is less than 5 years.
So I'm going to have you all do some exercises so you can practice writing null and alternative hypotheses. To get to this information, go to my data science, go to my website, kelseyhunsberry.com, go to data science classes, scroll all the way to the bottom, and go to statistics and R, PowerPoints, code, and data. Click on that, and then we are in the third class here. Go to and find the hypothesis generation works. This one has answers. Choose the one without answers, so this one, and you'll want to open it. And then just fill out this worksheet that you'll see here. So go through. The first part is writing them out with words. The second part of the page would be writing them out with just symbols and short phrases. So fill this out and we will go over the answers as soon as you are done.
The first example, I tried to use examples that would actually come from a job or closer to that, the things that you would be looking at, because I think the examples in the PowerPoint aren't most ideal in that way. After a renovation and build up in a public transit system in Austin, we wish, the percent of individuals driving to work decreased. So I put as my HO or null hypothesis, and this is in the shared folder now. The percent of people driving to work after the transit overhaul was equal to or greater than before the transportation overhaul. And wording can be different, but that would be the gist. So it's the opposite of what we're trying to prove. And then the alternative hypothesis would be the percent of people driving to work after the transportation overhaul was less than before the transportation overhaul. So what we're trying to prove up here. This is more of a what you would have at Whole Foods. I'm gonna actually zoom in, I apologize. So sales at H-E-B grocery store in downtown Austin rose between August and September when the nearby competitor Whole Foods Market closed. This is actually a project that I'm working on, is how sales change when one grocery store closes versus adding a new grocery store. So sales in September at H-E-B in downtown Austin were less than or equal to the sales from August. And then our alternative hypothesis would be the sales in September at H-E-B in downtown Austin were greater than the sales from August. So did they increase when the Whole Foods Market closed? That would be what we're trying to prove. Next would be a healthcare example. A new breast cancer screening tool correctly detected 96% of malignant cancers. If you know anything about mammography, that's actually an example I'm going to use. It's not that high. So the null hypothesis is the percent. It would be a new breast cancer screening tool did not detect 96% of malignant cancers, because it doesn't make sense the way I wrote it. So our alternative hypothesis would be that the new breast cancer screening tool detected 96% of malignant cancers. So that's what it actually would be.
Some of these questions like that one there, they're specifically testing
Difference.
well, you're looking for equivalence.
Yes. That's the piece that's you have to pay attention to. Is it greater than or equal to? Is it less than or equal to? Is it greater than, less than, or is it different, which would be equals versus not equals?
So in that case, though, I'm going to guess the intention is for them to see if it was better than a certain number.
No, in this cancer, did it detect 96% of malignant cancers? So if it says did it detect and gives a whole number, then that means that is equivalent. So it was 96%, it was not 96%.
Yeah, you were thinking about accuracy versus non-accuracy.
Yeah. Well, what was the context where they would want just the 96?
So if there was, say, something that already was on the market that had 96% as its established rate of detecting malignant cancers would be one. Another one would be, say that there's a certain threshold in healthcare that you have to find 96% or we won't use this tool because it's not good enough if we can't detect 96%. Those would be the most likely scenarios. Yeah, well, there's always a little wiggle room there, but this would, and then it might not be 96%. For instance, I'm going to use later mammography. There are false positives, I believe, about 13% of the time, and false negatives are between 7 and 12%. And we're going to go over that, but they still use it because it has more value than not. This was, as an example, most likely would be if another tool had 96%. So we will see if it's doing better or worse than the tool that's already on the market. And I know that there's a lot of, I went into this territory because I think that this is not something that everyone knows. So farmers that use genetically engineered seed developed to prevent rootworm use less pesticides than farmers who did not use this seed. I worked for Monsanto/Bayer, and this is one of the things that they're doing. They're building in the pesticide prevention into the seed so you don't have to spray the pesticide that kills the bees. So I will inject some of that because I agree the company does some bad things, but they also do some good things too. So I'm going to put that in there. So the null hypothesis is farmers that use the GMO seed use pesticide at an equal or greater rate than the farmers who did not use this. The alternative would be farmers using the GMO seed use less pesticide than the farmers not using the seed. So I'm sorry if that offends anybody, but so section 2, I just had you write it down with symbols. After Pepsi's new television advertising campaign, average daily sales were greater than $1 million in the US. So this would be greater than versus less than example. So we would be trying to prove that, or there are null hypothesis, what we're assuming is mean sales are less than or equal to $1 million. Alternative is that they're greater than $1 million, the mean sales. Medicaid enrollment equaled 23% of the population in Pennsylvania after Medicaid expansion was passed. The enrollment was 23%, or the enrollment was not 23% versus the enrollment was 23%. I did a project at my first job that I went around and put in probably, I don't know, 35 Freedom of Information Act requests to each individual state to get county level Medicaid enrollment data. The counts of how many people were on Medicaid for, I can't remember how many years, it was a range of years before and after Medicaid. And one of my projects, it's actually written up online on a federal website, was looking at rural versus urban Medicaid enrollment changes before and after Medicaid expansion. So if you want to see that, it's on my LinkedIn. Well, it's asking here, did it equal 23%? And it did equal 23%, by the way. That's what we found the number in Pennsylvania was after Medicaid expansion. So it's not asking that. You have to see what the actual question is asking. So it's saying, did it equal 23%? And so we would assume that it did not equal 23%. And we would be trying to prove that it did equal 23%. I tried to vary the language here because you're going to see different depending on what your use case is. So, and here's an example of the greater than or less than. Greater than 50% of students at Chesterfield High School got a score of 1,000 or higher on the SAT. So students scoring, and it should be 1,000 or higher, is less than 50%. So that's what the null hypothesis we're assuming. Students scoring 1,000 or higher was greater than or equal to 50% would be the alternative hypothesis. So scoring, it should be this. Okay. Did you have a question?
For your null hypothesis there, should that be the one that includes the equal as opposed to?
It depends on what you're trying to prove. So in this case, we're trying to prove that it's greater than 50%.
Right, so your null, it was 50 with your null.
So it equals 50, you mean? So it would be not equals here, and then it would be equals here. So, and this should actually be also less than or equal to, because this is the opposite. Okay, so greater than 50% of students is in this case. So we're trying to test if more than 50% of students scored 1,000 or higher on their SATs at that said high school. So we're assuming that it's less than or equal to 50%, and then we're testing if it's greater than 50%. Yeah. So less than 30% of those who got the flu shot in 2018 had the flu vaccination. So that would be, you would be testing whether of those who got the flu in 2018, how many of them had the vaccine or had the vaccine. So vaccinated with flu would be greater than or equal to 30%. Vaccinated with flu, we would be looking to see if it was less than 30%. And then removing antibiotics from animals grown to produce meat lowered the percent of MRSA infections in hospitalized patients to 10%. So I'm saying, does it equal 10%, or does it not equal 10% in this case? And this is actually something that you see. Antibiotic resistance increases, it makes people more susceptible to antibiotic resistance in hospitals with MRSA. So, so this would be something that somebody might want to look at. Playground injuries requiring medical attention decreased to 5 students or less per year at Hamilton Elementary after the merry-go-round was removed in 2006. So injured students greater than 5 or injured students less than or equal to 5. 5 students or less, so that's where that's coming from. So hopefully that helps. Keep track of the time.